Hi guys and welcome back to Math Ease with Miss C. In today's video, we're going to learn everything you need to know about the HCF, which is the highest common factor. You'll learn what the HCF is, how you calculate it, and easy tricks to help you solve word problems related to the HCF. So make sure you watch the entire video. Now, before you get worried and think this is the wrong video since you came here looking for the GCF or the GCD, here's a little secret. HCF actually goes by 3 different names, but they all mean the same thing. Let's take a closer look. Sometimes in math, you'll see the same idea written in different ways. For example, the HCF, which stands for the highest common factor, the GCF, which stands for the greatest common factor, and the GCD, which stands for the greatest common divisor. At first, it might look confusing because of the different words, but they are just 3 different names for the same thing. If you take a closer look, you'll notice that factor and divisor are basically the same word in maths. They are numbers that divide another number exactly. Similarly, highest and greatest mean the same thing too. So whether someone says HCF, GCF, or GCD, don't get scared. They're basically talking about the exact same thing. Quick question. Which word have you heard before? HCF, GCF, or GCD? What word do your teachers normally use? Let me know in the comments so we know which one is more popular. Okay, now let's actually understand what the HCF means. The word itself tells us a lot. Highest common factor. Factor means numbers that divide evenly. So we're going to find the factors of different numbers. Common means something that 2 numbers share. So we're going to look at factors that are common between them. And highest means the biggest one out of all the common factors. So basically, the HCF of 2 numbers is the biggest number that divides both of them exactly. See? It's not that difficult. It's always a better idea to see this in action with an example. We'll find the HCF of 24 and 36. But remember, we're not going to use the proper method just yet. Right now, we're just going to understand what it is, since that will help us out a lot later on. First of all, write down all the factors of 24, meaning all the numbers that 24 can be divided by. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. These are all the numbers that the number 24 can be divided by. Now, let's write down all the factors of the number 36. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Okay, so now take a careful look at both the lists and find the numbers that are the same. These are called the common factors. The common factors of 24 and 36 are 1, 2, 3, 4, 6, and 12. These are the numbers that both 24 and 36 can be divided by. Finally, out of all the common factors, choose the biggest one, which is 12. So we can say that the HCF, GCD, or GCF of 24 and 36 is 12. Now here's a little challenge for you. Can you try finding the HCF of 18 and 30 using the same method we just used? List down all the factors, pick out the common ones, and then tell me the highest one in the comments below. The example I just showed you was to help you understand what the HCF is. But in math, we find the HCF using a method called prime factorization. If you missed out on our video on prime factorization, make sure to check it out. I'm sharing it in the description box below. Let's find the HCF of 24 and 36 again, the same numbers we did in the last video, but this time using the prime factorization method. So the first step is to write 24 and 36 side by side and a comma in between them. Make the same lines we did for prime factorization. So start dividing with the smallest prime numbers that can divide both the number 24 and 36. Since 24 and 36 are both even, we can divide them by 2. So let's do that. 24 divided by 2 is 12. And 36 divided by 2 is 18. Now let's check it again. Can both 12 and 18 still be divided by 2? Yes, they can. So 12 divided by 2 is 6 and 18 divided by 2 is 9. Now take a look at 6 and 9. Can both of these numbers be divided by 2? Not really. 6 can, but 9 can't. So we move to the next prime number, which is 3. Can both 6 and 9 be divided by 3? Yes, they can. So we're going to divide them by 3. Remember, in HCF, GCF, or GCD, you have to make sure that both the numbers can be divided by the prime factor that you're using. So 6 divided by 3 is 2, and 9 divided by 3 is 3. At this point, 2 and 3 cannot be divided by the same prime number anymore. So we stop right there. This is the first step that you need to take. After that, to find the HCF, you have to multiply all the prime numbers that you've written on the left over here. In this case, those numbers are 2, 2, and 3. So what we're going to do, we are going to write that the HCF of 24 and 36 is 2 times 2 times 3, which equals to 12. See how clean that was? Instead of writing big lists or separate factor trees, we just divided both numbers side by side until no more common prime numbers were left. Moving on to the next example. This time we have to find the HCF of 30 and 45. So let's do the same thing again. Write 30 and 45 side by side just like we did before and make the same lines. Start by dividing the smallest prime number that works for both. Can both be divided by 2? 30 can because it's even, but 45 isn't. So we can't really divide them by 2. Let's move on to the next prime number, which is 3. Both 30 and 45 can be divided by the number 3. 30 divided by 3 is 10, and 45 divided by 3 is 15. Now, can both 10 and 15 be divided by 3 again? Not this time, because even though 15 can be divided by 3, 10 can't. How about the next prime number, which is 5? Yeah, both these numbers can be divided by 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. Now you'll notice that 2 and 3 cannot be divided by the same prime number anymore. So we stop right there. Again, take all the numbers that you've written on the left and multiply them. In this case, we're going to write that the HCF of 30 and 45 is equal to 3 times 5, which equals to 15. And there's your answer. Okay, enough with the small numbers. Tests and quizzes aren't always going to have two-digit numbers. Let's start with a bigger example. Finding the HCF of the number 120 and 168. So let's try solving this by prime factorization. We'll write 120 and 168 and leave space on the left for our prime numbers. Make the lines like we always do. Start by dividing by the smallest prime number, which is 2. Since both numbers are even, we can divide them by 2. 120 divided by 2 is 60. 168 divided by 2 is 84. Now we have 60 and 84. Can they be divided by 2 again? Yes, they can. 60 divided by 2 is 30, and 84 divided by 2 is 42. Since we have both even numbers again, let's keep going on with 2. 30 divided by 2 is 15, and 42 divided by 2 is 21. Now, can we divide 15 and 21 by 2? No, we can't, because they're not even. Let's move on to the next prime number, which is 3. 15 divided by 3 is 5, and 21 divided by 3 is 7. So write 3 on the left and the 5 and 7 on the inside. Can 5 and 7 be divided by the same prime number again? No, because they're both prime numbers themselves. So we stop here. Multiply all the numbers we wrote on the left to find the HCF. So what are we going to write? We're going to write that the HCF of 120 and 168 is equal to 2 times 2 times 2 times 3, which is equal to 24. And that's our answer. 24 is the HCF of 120 and 168. Okay, now let's make things even more interesting. But this is the last one, I swear. Let's find the HCF of 3 numbers at the same time: 56, 42, and 98. We'll write 56, 42, and 98 and make the lines like we always do. If you've noticed, all 3 numbers are even. So we're lucky right now, and we can divide all of them by the number 2. 56 divided by 2 is 28. 42 divided by 2 is 21. And 98 divided by 2 is 49. Now, can the numbers 28, 21, and 49 all be divided by 2? Of course not, because 21 and 49 both are odd. So we move on to the next prime number, which is 3. If you use the divisibility rules or try dividing them, you'll find out that both 28 and 49 are not divisible by 3. So we skip 3. Remember, all 3 numbers need to be divided by the same prime number. Similarly, we can't divide any of these 3 by the number 5. So how about 7? Yeah, 7 works. 28 divided by 7 is 4. 21 divided by 7 is 3. 49 divided by 7 is 7. Now we can't divide any further since they don't share any common prime factor anymore. So we stop right here. The next step is to multiply the prime numbers we wrote on the left. So the HCF of 56, 42, and 98 is equal to 2 times 7, which is equal to 14. And there you have it. HCF has never been easier. I hope you feel the same way too by now. Want to put yourself to the test? Try finding the HCF of 90, 150, and 210 using the same method. Okay, so far we've learned what the HCF is and how we calculate it. Now we're going to take things a step further. We'll learn how to apply HCF to real life word problems. So without wasting any time, let's move ahead. But wait a minute.
Wait a minute.
Before we jump into the word problems, let's first understand when we actually use HCF in real life. We know that it's a HCF problem when something has to be divided into equal parts, or when we need to make groups or distribute something equally, or if we want to find the biggest size that can fit exactly into two or more things. Whenever you see a problem that talks about equal division, grouping, or largest possible size, that's your clue. It's a HCF problem. And now let's solve our first word problem together. A merchant has 120 and 180 liters of two kinds of oil. He wants to sell the oil by filling both kinds into tins of equal volumes. What is the greatest volume a tin can have? Now, if you remember the first point we mentioned before, dividing something into equal parts, you know this problem fits that description perfectly. We are dividing the oil into equal parts and finding the greatest volume a tin can have. The word greatest is a hint in itself. This means we need to find the HCF of 120 and 180. Let's begin by writing down both 120 and 180 like we always do. We make the lines that we use for prime factorization. Now, let's divide them by 2 since they're both even. So 120 divided by 2 is 60 and 180 divided by 2 is 90. We have even numbers again, which means it's time to divide them by 2 again. So 60 divided by 2 gives us 30, and 90 divided by 2 gives us 45. So now, since both numbers can't be divided by 2, we're going to try dividing it by the next prime number, which is 3. And yeah, both 30 and 45 can be divided by 3. So 30 divided by 3 gives us 10, and 45 divided by 3 gives us 15. If we try to divide them by 3 again, we'll notice that even though 15 can be divided by 3, 10 can't. So we stop using 3 now and move on to the next prime number, which is 5. Both 10 and 15 can be divided by 5. So 10 divided by 5 gives us 2, and 15 divided by 5 gives us 3. It's time to stop right here, since 2 and 3 can't be divided by prime numbers anymore. Why is that? Because they're both prime numbers themselves. I hope you all remember what we have to do next. We multiply all the numbers on the left. So that's 2, 2, 3, and 5. So we are going to write that the HCF is equal to 2 times 2 times 3 times 5, which is 60. This is the HCF, which is our final answer. So the greatest volume tin the merchant can have is actually 60 liters. Let's try a different question now. But this time we're going to go for one that explains the last point that I mentioned in that list of 3 points, which was the biggest size that can fit exactly into 2 or more things. Okay, so here we go. A school has 2 rectangular playgrounds. One is 84 meters long and the other is 108 meters long. The principal wants to divide both playgrounds into square plots of the largest possible size so that no space is left over. What should be the side length of each square plot? Did you notice how the key phrase here was the largest possible size that fits exactly? That's your hint that the problem is about HCF. The words largest and fits gives it away. Now, back to the first step, writing the numbers down, which is 84, 108. And we make the lines like we always do. So, since both the numbers are even, we're going to divide them by 2. 84 divided by 2 gives us 42, and 108 divided by 2 gives us 54. Both numbers are even again, so let's divide them by 2 again. 42 divided by 2 gives us 21, And 54 divided by 2 gives us 27. Now, both of these numbers are odd, but luckily, even though they can't be divided by 2, they can be divided by 3. So 21 divided by 3 gives us 7, and 27 divided by 3 gives us 9. Now we have to stop here because even though 9 can be divided by 3, 7 can't. And unless both numbers are divisible by the same prime number, we have to stop. So now you know the drill. Time to multiply the numbers on the left. So the HCF is equal to 2 times 2 times 3, which gives us 12. So our final answer is 12, meaning that the side length of each square plot should be 12 meters. Now, don't think I'm going to let you off the hook so easily. Now it's your turn. A tailor has 2 rolls of cloth. One roll is 90 meters and the other is 150 meters long. He wants to cut both rolls into pieces of the largest possible equal length without wasting any cloth. Write your answers in the comments below and let's see how many of you get it right. And don't worry if you don't. I'm always here to help you out. If you enjoyed this video, hit the like button, share it with your friends, and subscribe to the channel for more math lessons that are going to make math class very easy. That's all for today. Remember, don't hate math, keep practicing, and I'll see you in the next video. Bye!